All right, let's try to stick on time and get started. So my name is Aniszczyk. I have the fun job of running the Cloud Native Computing Foundation, and today we're chatting with a bunch of folks about the future of service mesh. So to get started, why don't we do some quick introductions on the panel, and then I'll dive in some questions, and then I'll definitely leave enough time for the audience to ask some questions. So go ahead, since you
Is this one on?
Yeah.
Okay.
Hear you loud and clear.
So I'm going to introduce myself again. Hi, folks. I'm Prajakta. I'm a product manager in cloud networking in Google Cloud. My team builds out a series of products, including related to load balancing, CDN, network security, and now again for Istio, and then the managed Istio pieces like you heard about Traffic Direct and so on. So really excited to be here.
Thank you. Hey, my name is Suresh. I'm from Yahoo. Now it is Verizon Media. I lead the effort where we do lots of container, Kubernetes, and Istio in the last 2 years. We are not in any public cloud, even on-prem, and we run. It's a good question. Why? And we run one of the largest on-prem Kubernetes cluster, and yeah, we've been early adopter of Istio. We've been working with Google for the last 1 year. Thank you.
Thank you.
Hi, it's Sang. Okay, great. My name is Len Sang. So happy to be here. I'm one of the maintainers on the Istio project. I was just counting. I think I made over 100 PRs to the Istio repository now. So work for IBM. Been working with, spend most of the time doing community work within Istio.
This is so awesome. If I have a feature request, I'm right next to the person. I'm Bernard Golden. I'm Vice President of Cloud Strategy for Capital One. Capital One is pretty well known across the industry as having announced it's going to go all in on public cloud. We have a fair amount of Kubernetes in production, but we also have lots and lots of virtual machines in production as well. And I think the service mesh topic is a really interesting one, and I want to thank the event for inviting me to participate. Yeah, cool.
I'm Randy Bias with Juniper Networks. I run open source strategy for them, amongst sort of, I guess, a bunch of other hats that I wear at various times, including being cloud pundit guy. Anybody familiar with the pets versus cattle thing?
Yes, that's yours.
Isn't
that yours? I thought it was attributed to you.
Yeah.
That is total humble brag.
But a lot of people here probably don't know me, even though we've been around, Bernard and I, talking about and blogging about cloud stuff since 2008, 2009. And service mesh is one of the first things I've seen in a while that's gotten me really excited. So pretty excited to be here and talk about some more.
Cool, awesome. So, I mean, I'm personally a little bit excited because we have a kind of a mixed bag of folks here. We got, let's say clouds, Yahoo and users, Capital One, however you want to classify Juniper Networks. So it's a good crowd. So the first kind of question I have is, one thing we kind of struggled in at least CNCF and Cloud Native land is, anytime you ask someone, what define Cloud Native, what do you think about Cloud Native? What does it mean to you? You get different answers, right? And so I kind of see things repeating themselves a little bit in service mesh land. Everything kind of, it means different to different folks. So I kind of would like to know, how do you, what does service mesh mean to you, and kind of how you define it within your respective organization. So feel free to start any way you want, whoever wants to go first.
So I mean, it's nascent, right? That's the good part, right? I mean, there's not a clear definition, so you get to help make the definitions. That's the way it was in the early cloud days. So that part, I like. I can't say that I speak for all of Juniper. I'm sure even within Juniper, there's a lot of different perspectives. But for me, the aha is that we have taken the communications layer inside the application and basically distributed it into the network. And for me, that's really powerful for a couple of reasons. One, that communications layer is now the same regardless of what language you're using or what your application is, whether it's Java or Python or C or Go or whatever. The communications layer between the microservices, the application components, is always the same. And so when you standardize, it does create a lot of tension because people, have to figure out how to do the new thing. But the flip side of it is now you can do some really interesting things, like the fact that we have common telemetry in between all the microservices. I think that is like really, we're just at the tip of the iceberg about what we can do now in terms of getting insight, and what people are talking about is observability now into how the application tiers are talking to each other. And I think that's very powerful. And then the second thing is that, when I was running my OpenStack startup, we were like, hey, everybody should build a public cloud or a private cloud that looks like Amazon, and we want to take this prescriptive approach, but nobody wanted to do that. They all wanted to build their own science project. The fact that Kubernetes is one and has a standardized approach, and now service meshes have another standardized approach on top of that about how the application layer communicates in between its components, I think that actually allows you to do a whole bunch of things that we're just beginning to see in terms of security, in terms of identity, a lot of things that were talked about today. And that's a really big thing, because when you take a prescriptive approach and you know what every application is going to look like, regardless of the language it's coded in, regardless of the framework it's coded in, and regardless of where it's running, then suddenly you have a lot of power.
Yeah, I guess one of the key words when I think about service mesh is the word of extract. So the way I'm thinking about it is extract a lot of complexity from networking, from telemetry or tracing or security from the user, so the user doesn't have to worry about it and sort of trust us from whether it's Istio or AppMesh to deliver that extraction for them as part of the framework. So that's really the power and nutshell of the mesh.
In one sentence, service mesh for me enables application networking. And what I mean is like, hey, where you can control how the application shares data, and it controls how securely the data can be transferred. At the same time, it's a common way of doing authentication and authorization, image enforcement. It's one way of doing it so that we're not duplicating it across when we have a number of languages which we bring into the container world or say any VM world too. Okay, standardizing that process.
I think I'm probably just going to echo a lot of these sentiments. And a few years back, I was sitting in a stage like this on a panel, and somebody asked me, and I'm from the networking space, which is probably obvious by now. Somebody asked me, how do you define software-defined networking? And I'm sure you've heard a lot about that too. And I said, and this is of course my interpretation of things, and I said, you had these boxes which did a multitude of functions. They had proprietary interfaces. It was all smushed together. Every box was its own snowflake. And what you did is essentially you separated out the control and the data plane. The data plane became extremely simple. You put a lot of the intelligence into the control plane. And what that really allowed people to do is to go innovate on each of those layers independently. And it also made the data plane extremely simple. And in some ways, I think of service mesh as SDN for services. And I don't particularly ask people to adopt it because it's cool, which it is. But it's also for the same thing, like you have these services, each of which looks different. It's extremely hard to manage those services. And so imagine if you could take a service, and then what you worry about is your application and your business logic. Then take some of the networking code that needs to exist in the data plane, put something like an Envoy proxy next to it. I know Matt gave a talk on the universal data plane. And then you build out a control plane which can go and feed intelligence, which can aid observability, which can go aid security. But then you have this control plane, which is a very consistent experience. Make sure you keep open interfaces between the control and data plane, because that's when each of these layers can really evolve. And then, to me, what all of this translates to is also consistency. So I am able to use the same paradigm, whether it's services that are sitting in Google Cloud, if they're sitting across multiple clouds, whether it's a mix of VMs and containers, and most importantly, like Eric Brewer said in the morning, if you want to deliver services at scale, having consistency is almost like a prerequisite, and that's what service mesh enables. So I'm really excited for it. I do agree that it's one of the most exciting things to happen in recent times, and I echo Randy's sentiment on that.
Cool. So, go ahead, Bernard. Sorry.
I guess the thing that I find quite interesting about service mesh is it is sort of pulling out configuration stuff from the executable environment to a sort of maybe a centralized place that it can then be distributed and punched in, which makes it simpler to operate. You get to be able to have expertise at someone smart can do it one place, and then it can be put everywhere. It has the potential, at least, to reduce the cognitive load. So, as I said, we have people running Kubernetes in our organization. And the challenge for application groups is they end up having to be experts at running a lot of plumbing, and that's a challenge for them. And we would like them to use more of their cognitive load, their cognitive ability, on business functionality, not plumbing. And so this kind of higher level abstraction gives them the opportunity to spend more of their brain power on delivering great stuff for our customers, rather than sort of every group having to figure out how to manage this stuff. And of course, one of the challenges you get when you have that sort of environment is you end up with a lot of snowflake environments that, and the challenges I think are probably pretty clear.
Good. Yeah, it's, I mean, I think my bit of advice maybe for the service mesh community, something we struggled in cloud native land, is we eventually got together, took us 6 months or so, and came up with like kind of a standard agreed upon definition. So maybe that's my challenge for everyone here to kind of go through that exercise. But to Randy's point, I think it's still a very nascent field. Like, there's still a lot of early adoption and usage, and especially for kind of the end users on this panel, like, Suresh and Bernard. Where are you on your kind of like service mesh journey? Like, why did you decide to go into it? How far are you along? What are you using? And kind of, let us know how you got there.
Sure. So what we did in last 2 years was lift shifted lots of legacy workload, which was running on VM world, into container and Kubernetes. And that's the first thing we did. And once we did that one, the next thing was like, okay, fine. Now we need to make sure that we should protect all this workload which is running on this Kubernetes workload environment, right? And we are like 100K containers we are running out there. And then we need a platform where we want to make sure that without making code change to all this application which has been run for like 10 years, 15 years, it's been there, it's been running forever, making millions of dollars for us, but still we want to bring this, secure that environment, secure the application without making a code change. At that point, I was looking into and then said, okay, fine, that was the right time Istio was introduced, and I got interested in that one. Let's see what we can do about it. And then I engaged with Google. I started with 0.4 version of Istio, I think, and engaged with Google and got to Istio into Yahoo. Right now, what we do is, we are in production as we speak, and then we use Istio only as an ingressing solution, not as a mesh solution yet. Okay. One of the things which blocked us from going mesh-wide was we have our own certificate authority. Okay. Citadel, the one which is built with Istio, was not supporting a third-party certificate authority. So we want to come up with a solution. We came up with our own identity framework, and we worked with Kubernetes app SIGAT group too, and presented there and said that we built that complete model where every container today has a unique identity built and in the form of expired generalized certificate, and it's been given to the container. Once we did that work, which kind of took little time for us, and now what we do is we build that framework where we provide an expired generalized certificate for a container. Now the envoy proxy uses that certificate and listens and then use that certificate as a client certificate. Now we are making progress today, making this across mesh. Okay, that's one part which kind of slowed us from going production mesh-wide rather than we are in production as an ingress-wide today.
Okay, cool. I mean, I consider Yahoo more of kind of internet scale company, early adopter. Bernard, what about, you're a bank that's becoming a tech company. I get it. Like, so, like, where are you kind of on your journey?
I was a little worried when I saw I was on a panel about the future of service meshes, because really, I would say we're starting to move toward them. But what I would say that what's become clear, I think, within sort of architects and so forth, people who are looking forward within Capital One, is that the Kubernetes ecosystem is going to expand to include Istio, and very likely Envoy will be a very strong player in that. And so if you're going to say we want to use containers, you're going to say I'm going to want to use Kubernetes, and that's going to lead to this kind of thing. And so we were not only at this event, but we were also at gRPC Day last week, and very clear kind of consistency that we're going to probably be looking forward to engage with. And we're starting to rethink about, well, how do we have to redesign what we've got in place? I will say, I will talk a little bit about the futures thing. I think that eBPF is quite interesting and something that we want to pay a lot of attention to, because I think, I don't know how all the other companies do, but it strikes me that the performance implications of process switching versus being able to stay within the same executable, probably pretty important. And I'm quite intrigued by Eric Brewer's conversation this morning where he talked about offloading to hardware. And if there's somebody here who knows about that and would like to have a conversation about it, I'd like to find out more about it, because that would be quite interesting.
Just to jump on that real quick, you didn't ask me, but one of the things at Juniper that we're trying to figure out is how do we interact with Istio and Envoy, right? There's overlap with our projects like Tungsten, which is our SDN controller, and we've been thinking about stuff like that. And one direction we're starting to look at is adopting eBPF as like a universal data plane at that networking layer. So we know if it's running Linux, it's got eBPF, we can control and manage it and sort of just act as the control plane. And then that starts to beg the question of, do we control Istio? Do we control Envoy? Do we act as a meta controller from the network, from layer 3 all the way up to layer 7? Or, so we're asking ourselves a lot of those questions. But, I think a lot of this stuff's going to converge at one point, right?
To your point, earlier you made a comment like, oh, it's like Kubernetes is now kind of the standard. It's all honky-dory. It was a painful, 3-4 years to get there. And then you mentioned service mesh is getting it standardized. But I kind of view those as, Kubernetes is a project, right? Service mesh is more of a pattern. It's not a project, right? So I kind of see, similar things potentially maybe playing out in the service mesh space where there are lots of options, some overlap, lots of projects. How do you see that playing out over time? I mentioned eBPF you mentioned, but like kind of what else do you see happening in this space?
Well, hey, I came up with eBPF, so I feel like everybody else has got to come up with something.
So I did a presentation a long time ago called the Elastic Cloud Story, and I tried to almost articulate all the different patterns there were, which, there's a lot more now, right? Circuit breaker was the hotness at that time. And one of the things that has been really clear is that we're not going to turn the average enterprise developer into a cloud-native application developer anytime soon, right? It's just not going to happen. So the part of the power of extracting things out of Kubernetes, which doesn't need any more complexity and putting them into the service mesh, is that we can start to play around with a lot of these patterns. I mean, we're just talking about the global load balancing solutions, and everybody has to solve these same problems over and over again, and it is a net negative benefit if everybody is reproducing the wheel. We would rather sort of work as a team to figure out the best patterns that make sense, put them in those places that make sense, whether it's the service mesh or Kubernetes, and then empower the average developer to be able to consume and use those things in a way that makes sense. And so, I don't know what the future holds, right? I'm not an expert on service mesh. I mean, like Bernard, we're still exploring, but I do know that historically the same thing happens over and over. I mean, I don't know if anybody remembers e-commerce days in late 1990s. Everybody was like, how do we build this? And now it's like template, right? Web app proxy, database tier, it's always the same. So, I think that we're going to figure it out as we go along.
I guess I would think service mesh as when we compare with Kubernetes, I would think about container orchestration system, right? So Kubernetes is kind of win the battle for container orchestration system. For service mesh, I think the industry is coming together with a definition, and there are certainly a lot of involving projects out there. I'm definitely on the Istio camp, as you can see with my Istio shirt a little bit inside. But there are a lot of projects out there. I think whoever is going to produce the most transparent service mesh is going to win with the most usability. To me, the service mesh should be as simple as I'm an application developer. I should be able to run one single command and add my microservices to the mesh. And if I don't like it, I should be able to run another simple command to exit out of the mesh. We are certainly not there from an Istio project perspective, and probably many of the other projects out there. So I think that's one perspective. The other perspective I would say is also the community and governance, right? So as far as right now, Istio is not a CNCF project, which worries me a whole lot, right? So I think it needs to be a CNCF or governance managed project to win that battle, who is the best service mesh out there. The community support is also amazingly important, and I think that's where Istio kind of shine right now. We have a lot of growing community members who contribute to Istio. I think last time we did a count, we have about 300 to 400 members of the community, which means any of these members at least made one single PR, probably more, to the Istio repository. So that's a really growing sign of the community.
Yeah, it's from my perspective, it's just going to be a little bit entertaining to watch because I've seen there's a lot of data planes out there. Some control planes. Some people are rolling their own control planes off of like Envoy and other things. And also in the news, you see like F5 buys Nginx for quite a bit now, and Nginx is now a service mesh company. Some of the traditional API gateway companies were a service mesh company now. So it's just going to be funny to kind of see this competition in the space. So. I wanted to make sure that we would have time for questions from the audience. So we have a...
Actually, I'll just add one
sure.
thing, which is the last thing, because it was really interesting to hear all of these viewpoints. And I think it's too early to say that we have a service mesh that rules them all.
Yeah.
But I do think it's very critical to ensure that whoever builds something builds it out with open interfaces, because if you're going to lock the customers into something, it's very hard for all of these service meshes to converge into a few opinionated and good solutions. And I think that's the key of it. So as an example, when we built out Traffic Director, one of the key tenets was that Envoy, just like Kubernetes, Envoy is one of the most dominant service proxies, and it has an open API, which is XDS v2. We actually evaluated it on its merit. It's an excellent API. It's extensible with filters, and that's why we chose it. Now, even if you're an Nginx or somebody else, you could choose to actually support those open interfaces, and you could be that proxy too. So I think, and similarly with the data plane, like we have Pilot, where Google is a big participant in the Istio community, but then you also have Traffic Director. They both use XDS v2, and that gives you a choice. So you don't get locked in, and I think that's the crux of it. Like we just have to preserve these open interfaces.
Yeah, it's always a little bit more political sometimes than that.
Actually, it's fairly no-brainer in my mind, but then that's my opinion.
Yeah, I remember the container wars and all that fun stuff. So we have about 5 minutes. So I'd love to get some questions from the audience. If there's any, there's one hand already. So yes, gentlemen.
Okay, I'm from Visa. My name is Anil. So this question is not for Google. I'll ask a follow-up question to the Google answer. Okay.
That's good. Go for it.
So we are going to run thousands of services, right? So applying the network policy with a few of the services easy, okay? But when you're handling thousands of services, what's your view? How are you going to manage all these services without the traffic director, okay? How you're managing within your own organizations, because otherwise too quickly it becomes too difficult to manage, right?
Do you want to answer first, and then I can go?
So when you say policies, you're talking about network policies?
Network policies are based on the service mesh, right? So any traffic management or traffic.
So, yeah, the question is, you have thousands of
Thousands of
services
services.
and network policies. How do you manage them?
Yes.
You can't do it manually. So.
Definitely not. We are not there in that scale yet, at least in the service mesh world. Okay, and
What's your view, like what you're thinking about?
like my view will be is like, okay, fine, now Kubernetes itself, right? If you look at Istio, it's built based on Kubernetes extension with CR, right? So now with everything built into Kubernetes API as an extension, right? We have one single place where we have all the policies are stored and defined out there. Now, like if you have an agent like Kubelets, which is sitting out there, which is watching for this internet and applying the changes very uniformly, like today we have a biggest Kubernetes cluster with 1,000 plus nodes, 1,000 plus service. If that can apply in a very unified way, I don't see there to be any scaling problem. We haven't tested that yet, but this is my view of saying that I don't see any scaling problem as long as we have everything stored in Kubernetes API and we have agents sitting here fetching this data and applying it locally, or we have a sidecar which is sitting here fetching the data and applying it locally, and the data has to be very small. We ran into issues. But if that is there, we constrained within the namespace or the bunch of namespace we want to play with, I don't see any scaling issue.
I'm not talking about more of scaling issues. I'm talking about the manageability of the network policy. Are you planning to apply some kind of RBAC and segregate the duties, and somebody is going to manage it through some kind of CICD pipeline, or how is that?
So if you joined our talk yesterday, we talked about how we are building RBAC for this application, right? It ties to the same thing. So we have our own CA, right? And we also have our own RBAC, which we open sourced called Athens, right? Where that is kind of completely user driven. It's an UI where you go back and then say that, hey, this is a service, I want to whitelist the other service, right? You define out there. But at the end, what is translating from that particular UI is a controller which is translating into service role and service role binding in Kubernetes only. Okay, so that's how I see that, hey, where you make the change out here, Kubernetes API gets it, and then we propagating the changes. And I hope that answers. If we had attended our, yeah.
How are you managing that all now in your legacy systems?
Even in the Kubernetes, we are managing through much like a CICD.
The manageability of all your global network policies, your firewalls, your VPNs, you have a single pane of glass, RBAC control.
Yeah. So I can add to that. Now I'll answer the harder question, which is like, what do you do? So I don't think we are all going to land up on one single policy framework. So that's not going to happen. You have stuff on-prem. Even when you say policy, it's a very loaded word, right? Even when you say network policy, if you asked 5 people in this room, they'd probably tell you something different. So I think one of the things that you mentioned, which I'm a big supporter of, is having your configuration as a CICD pipeline. In fact, we have a Canadian bank. It's one of our big customers. They have 11 types of policies, but the entire configuration and lifecycle management of that is a CI/CD pipeline. It works beautifully because your change management is just so much more palatable than like point manually or whatever, even automation. The CI/CD pipeline, I think, is a no-brainer, at least based on the tools available today, to automate and then just get it right, because otherwise there's too much risk of getting something wrong. I think the second part of it is, now this is again my personal opinion, not Google's, but somewhere in the future you are going to have some dominant sets of policies, and I believe, like, take some security policies and so on and so forth, and you brought up RBAC and so on. If you start really having your service mesh span multiple locations where the policies look different, there will be some sort of federation. So it's not like they'll just merge into one, but they will be able to understand what the other side is, of course, in a controlled manner. And I think the service mesh makes it much easier to get to a model like that, because there are well-defined interfaces, things look uniform. That's essentially a good substrate to build out something like that. In the meantime, I think what helps is automating with the CI/CD pipeline and getting as much single pane of glass visibility as possible. I know it's not perfect, but at least making the attempt to get there takes away a lot of the toil of it. So. It is open source, so you could use Pilot in some sense and you get it. I think the value add of Traffic Director is to take all of Google's edge infrastructure. So imagine that this infrastructure has been in use for Google's own services for 15 years, because we've had a service mesh internally for 10, 15 years. Like, that's the paradigm. And even the service mesh control plane exists. This control plane is globally distributed. It's massively distributed. It keeps getting microservice. So if something gets too big, it gets chopped up and deployed, so it's not a single point of failure. What Traffic Director is doing is taking all of the service mesh abstractions and layering it on this global infrastructure and then giving it to you so you don't have to build it. So that's what it is. You already have it.
Thank you. I think both of you
Thanks.
One final question. Yep. The question was, what are your thoughts on the future of serverless and service mesh? With service mesh. Serverless plus service mesh.
Does somebody
Serverless.
else want to take it, and then I can chime in?
Sorry, I didn't mean to interrupt.
Oh, no, go ahead.
Well, it's clear they're going to coexist. I mean, there's just no doubt. Serverless is a very powerful paradigm. There's lots of potential there. I think we're only in you can't even really say about Kubernetes like, oh, it's a legacy thing or whatever. But I mean, serverless is even more nascent than Kubernetes container service mesh. I'm talking about for most mainstream organizations. But the serverless for environments that we use it in, at least, and environments that I've seen it being used in, it's extremely powerful. So I wish I could prognosticate about how they will be sort of connected in a service mesh, but that's beyond my brain power at this moment.
Networkless.
I think what I...
Sorry, had to do it.
Okay. I think what I would add is if all of us here get the service mesh right, like it's evolving, it'll take us some time, you could essentially have everything be serverless, right? If you think like as somebody who looks at the inside of serverless infrastructures, like Google has serverless, if you look at under the hood, it's essentially abstracting away the networking for you. It's abstracting away the infrastructure for you. And at least my hope is that somewhere, if we get all of this right, the eventual goal should be like you don't even have to see the service mesh control plane or the data plane. Like you just see these services. Some of them stay longer. Some of them disappear because you're just computing a function, returning the value, and moving on. So to me, everything will eventually evolve to a model where less and less of the service mesh needs to be visible to you unless you want to see it. Like if you're a network operator, in which case you're doing a different job. In the short term, I think these are all very complementary technologies. So we do have customers, like we have gaming customers. So for a subset of their gaming apps or the services, they actually use serverless, they use App Engine. And then for the rest of it, which is related to game matching and then the gaming servers, they actually are looking at service mesh, and they use, we shipped out a gaming server based on Kubernetes. So, and then they use the global load balancer for DDoS defense, and they are now asking us for UDP DDoS defense, which is a totally different talk, which is harder to solve. So I think all of these are very complementary technologies at this point of time, but I do hope that if we get service mesh right, it starts, at least the networking bits, the control plane bits start becoming abstracted out for you.
Yeah, I think I agree with that. Some of the example, we already see that service mesh and serverless pretty much come in together. At least serverless framework starts to leverage service mesh and be able to use it. It's the Knative project, which IBM, Google, and many of the other partners are a huge contributor to that project. So within that project, they are using Istio and leverage service mesh functionality from Istio and Envoy to provide that to the serverless framework.
That's a great point, yeah.
Awesome, I think that basically puts us at time. So thank you again, panelists.
Thanks, everyone.
This was
Thank you.
a fun discussion, and look forward to doing it next time.
Thank you.
Thanks, folks.